Hello everyone, my name is Rambuyon Christian Jopatsi, and we will be solving controlling cylinder problems using the Fluid Sim simulation software. So for our first problem, when start button is pressed, the cylinder extends and retracts for 5 cycles, and after the counter reach the set count, the sequence stops. Pressing again will repeat the cycle. The sensors B1 and B2, PNP type normally open, will check the retracted and extended positions of the cylinder respectively. So as you can see here, we have already created the I/O wiring for this problem. So as you can see, the common parts of this I/O wiring is especially the logic module, since we will be doing a function block diagram in this example. Next, we have the 24 volts and 0 volts. You have also the start push button, which is one of the important components. And now we will be focusing on the new components we have. So first, let's take a look here at this part, the B1 and B2. So first and foremost, this is the magnetic proximity switch and the capacitive proximity switch. Now these switches are connected to our sensors here in the distance rule, which indicates that as the as the rod extends in B1, B1 activates the proximity switch. B1 activates, and as it goes to B2, the proximity switch B2 activates. Now, first of all, we have also here the double acting cylinder, which we will be using in this experiment. Now, the double acting cylinder, the piston of a double acting cylinder is operated by the reciprocal input of compressed air at the front and back of the cylinder. The end position damping is adjustable via two regular screws. The piston of the cylinder contains a permanent solenoid which can be used to operate a proximity switch. Now, we will be moving on in here in our four-way valve. What is a four-way valve? The configurable four-way valve is a wave valve with four connections where both of its body elements and its operation models are user-friendly or user definable. Additionally, the pneumatic conditions can be closed with either blind plugs or exhaust. So here, since it has a, as you can see, the double acting cylinder has two ports. Now this indicates that it will retract and expand. Since we have two ports, we cannot use the two-way bulb, since a two-way bulb has only one port each at both sides, while the three-way bulb has only two ports at the input and one port for the output. So we cannot use this, since we have a we need a two port output for the double acting cylinder. So in using a double acting cylinder, it is preferable that we use the four-way bulb and the five-way bulb, since both has two output ports. So before I forget to discuss the parts of a four-way valve is ports 4 and 2 acts as the output, while port 1 is for the compressed air supply. Now, what is the compressed air supply? It provides the needed compressed air. It contains a pressure control valve that can be adjusted to output the desired operating procedure. So here is where our pressure or air pressure comes from. So this is considered our input. So later we will see its use. Now, as it is activated, as the cylinder is activated, the compressed air supply provides the needed air pressure to extend this piston rod, which causes it to expand. And as it is turned off, it is cancelled out. The compressed air supply is cancelled out or blocked, which makes the piston rod retract. Now here, for our port 3, this acts our exhaust. As you can see, we have also already chosen an exhaust. So here, we can only use this last 3 exhaust, as the first 2 exhausts serve a different purpose, which will be discussed in the future. So as we press our 4-way valve, we can see that we activated the spring returned, and also we activated a pneumatically or electronically switch. So here it does not, the pneumatically or electrically switch does not indicate that we have to manually press it or mechanically, but electronically by with the help of our SOL valve here, or the valve solenoid switches the valve. By means of a label, the valve solenoid can be linked to a valve that is solenoid operated. So here it is electronically or wirelessly connected to the switch here and here. So as we turn on the start button, push button, and it goes within the logic module, and in our Q0, it connects already to our SOL here at the 4-way valve, which then activates the piston or the double acting cylinder. Now here we will be discussing also the parts of a proximity switch, whether it may be magnetic or capacitive or even optical and such. Now for a proximity switch, we have our positive terminal, which is connected to our 24 volts, and we have also the negative terminal, which is also connected to our 0 volts. Now here is where is the sensor, is the main sensor of this proximity switch. Here's the main sensor and such. Now we must also never forget that when you see this sign, it means that it is normally active and such. Now also a quick small tip, you should always label the same for the distance rule and the proximity switch. For if you name the distance rule differently from the proximity switch, it will not function, or this will not be normally active or normally open switch. This will be closed. So you want it to be normally active or open for it to function or to serve its purpose. Okay, now that we have described most of the components in this I/O wiring, let's now focus on the inside of a logic module. Let us begin. Okay, now that we have already assembled our logic module, now the logics that we used were latching relay, AND logic, and the up-down counter. Now, first, what is the latching relay? Input sets output Q, or input is the first pin, which is labeled as S, and input R resets the output. So we can guess that the second pin is the reset. Now a latching relay is a simple logic memory. The output valve depends on the input states and on the previous output states. So as you can see here, um, as you can see here, this is our latching relay, and then it is connected to our AND logic gate, which is also connected to our latching relay once again, and then our latching relay is connected to our output. Now, for our first, let us discuss the AND. As AND is connected to the our latching relay here, it is also connected to our I2 here. So ensuring that as RS is activated, the AND logic gate is also activated once again, including the I2. Now, remember that as you can see here, our I2 is the magnetic proximity switch, or B1. So as latching relay is activated, the pressing start button, the magnetic switch, proximity switch, is also activated, and then as it once again goes here, as it's also activated here, and then in our second pin, you can see that it resets when the I3 is activated. So when the capacitive switch is activated, a reset occurs. Now, here in the important component in our logic module, since this is a counter function, we need a counter. Now, this is our up-down counter. As you can see here, it is defaulted set in 5 pulses. So for after, this indicates that after 5 cycles of retracting and expanding, it will turn off, or it will reset. Now for the three parts of the up-down counter, this first pin is for reset. As you can see here, a reset occurs, which also a reset in the first part. Now here is in the second pin is the count port. So this here counts the number of times that the piston rod is expanded and retracted. So after 5 times, it immediately resets, resetting here and then halting the formation here. Now here, this is the directive, so we will not much focus on this, but we'll be focusing on 2 of these ports. Now as you can see, this is our logic. So let's give it a try and press. Since this is normally open, we consider that. Then as you can see, there is a expanding, and this here expanded, then retracts, then expanded, then retract. So in our iron wiring, this is automatically on and off. But as soon as the pulses reach to 5, it will completely be cut off. So now let us view our I/O wiring for a better understanding and better grasp of the answer for the given question to us. So it says here that the cylinder extends and retracts for 5 cycles. So let's see if we have accomplished it. Now, pressing start and press start button. Let's count 1, 2, 3, 4, 5. As you can see, it has successfully extended and retracted for 5 cycles or times, as you can see here, and that every time that it surpasses B1 and B2, the magnetic switches also turns on and off. So once again, let us see. As you can see here, our switches activates and deactivates. Now since here, if you are curious why this is already on, since this is normally open and it is already near B1, it is automatically open. But as it goes to B2, it turns off. The proximity switch magnetic turns off, and capacitive proximity switch turns on. How does this once again activates and deactivates? This is with the help of the distant root, which is considered a sensor. So this is considered a sensor, so labeling it identically is a must and must not be labeled differently for a better efficient. Now, as you can see that once again, when we press the start button, the SOL is also activated this is since it connected to our output 0, it is activated obviously, and then it is wirelessly connected to the switch here, the pneumatic or electrical switch, uh, which then signals the four-way valve to turn on and off. Thus, you can see here that our piston rod or the double acting cylinder is activated, and there is an expanding and retracting action or motion that happens. So thank you everyone for listening. I hope you gained something from this video.